Alright, yes, welcome to the session, and I hope all of you guys are doing good. So let's get started with today's session. So we started this AI series where we went ahead and started with artificial neural network in the last session. And in this today's session, we are going to talk about convolutional neural network. And we are going to take one of the examples as well, which is a simple example, and we'll try to understand how it works, right? So we already discussed about the artificial neural network, and in the last class, we have also discussed that we are using artificial neural network when we are having structured data, right? Where we have a tabular data. I want to predict, let's say, house price, car price. I want to know whether my customer will purchase the products or not. So those type of predictions which I want to do, I can very well use artificial neural networks and I can solve those problems. But the problem with that network is that I cannot deal with images. Suppose I'm having images and I want to predict something from the image. So in that case, ANN is not very well ready to process this. And because of that, I can say that it's an extended version of ANN. CNN is an extended version of ANN, where first of all, I will get the information from the image. It's something like a data pre-processing, right? So I'll try to help you understand. So I'm getting this image and I will first convert this to a structured data. And then I will apply the ANN. You can think of like that, right? So this entire process is known as CNN. So again, this session is basically to give you the idea what it is, how it is. We are not going to talk about more of a mathematical part, but yes, as a layman, how you should be understanding these concepts. That is the reason we have come up with this particular session. So the idea is that I have an image and I will get the important things from the image, important information from the image. And I will go ahead and I will make this as a structured data. And on that data, I will apply the artificial neural network, right? That is the idea. That is the entire concept which we have, which is known as convolutional neural network. Now in this, we'll try to understand how we can go ahead and how we can get the information from the image. What all processes we have to follow. Basically, this part consists of multiple steps. This data pre-processing part consists of multiple steps, and that is what we will discuss. And then we will go ahead and we'll take one example and we'll try to understand how this is happening. I already trained the model. I already ran the model because it was taking a bit of time for me to train. So I don't want to waste time on this session. So I just did the training from my side already. I'll show you the entire solution. So let's assume I have an image where I have a dark part here. Let's say this is the image where I have the dark part here. This entire is a black color, and this entire is a white color, right? So this is all dark black color, and this is all white color. So basically, this is the line which is separating your black and white, right? So I can very well say that this is an important information in the image. So I want to capture this information in the image, right? So let's go and let's break it out into the mathematical part. So now my image will be what? My image will be this black and white. So there is a concept of pixels and RGB numbers, right? So let's say I have this image. This image will be broken down into multiple pixels, multiple RGBs. So this is my image coming in, where the white color is having RGB value as 0. So this is my white color, for which you can see all the RGBs coming out to be 0. And for the black color, the RGB is coming out to be 255. Right, once that is done, this is my image. Basically, you see, machine will not directly see the image. Machine converts the image to a number, and from that number, it processes the information. So this is the number which machine will see on the image. And from that number, I will try to get certain important insights from the image. The very first step which I will apply is I will apply there are various kernels available. Kernels are basically nothing but some of the filters, right? Kernels are also known as filters. I can have various type of different filters available, edge detector, face detector. So there are various different types of kernels are available. Basically, the purpose of that kernel is to go ahead and get the relevant information from the image. So once we have this image, we apply various different kernels, right? I'll show you one of the images also, one of the pictures as well. Just give me a second. So here you can see that. This is my input image, and you can see here we have a lot of layers coming in. This layer is basically nothing but your kernels. The purpose of these kernels is to get the important information from the image, right? Here you can see kernels are there. In every architecture, you will find that kernels, right? These are the kernels, which is also known as convolution layer, right? So let's go ahead and try to understand. So I will apply a kernel. So this is my input. Try to understand from the image. Let me go back to this image, which is looking a bit simple. Let's say this one. So this is my input, which is the image, and I'm applying some convolution, right? And then I will apply pooling and all those things, which we'll discuss. So here I will apply some convolution. Basically, I am applying certain filter, right? We are applying certain kernel. Let's say I'm applying a kernel called edge detector, right? There are different types of kernels available. You just have to apply that and you will get the information. Here, my interest is what? My interest is to get this edge. This is the edge, right? Between black and white. This is the edge which I want to highlight. That is my main purpose. The main purpose is that in the image, somehow I get to know that there is certain important information present at this point. That is the end goal. So I will apply one kernel here. Let's highlight the kernel with a blue color. This is my kernel, 3x3 kernel, let's say. Let's say I'm giving this +1, +2, +1. Let's say I give this 0, 0, 0, -1, -2, and -1. This is the kernel which I will apply on this. Basically, a mathematics I will do, right? I'll do a maths. And once I do this calculation, what will happen? I will get the outcome. I will get the outcome. The outcome which I will get is something like this. So this basically this kernel I am applying on this, right? This kernel I am applying on this. So for example, when I am putting this on top of this, right? On top of this, something like you can say, I am putting this kernel on top of this, something like this. Or actually, I will make it like this. Just give me a second. I'll remove this picture for now so that we'll have a better understanding. So I will put this blue kernel on this image, this part of the image, right? 1 into 0 is 0, 2 into 0 is 0, 1 into 0 is 0, everything is 0, right? So my outcome will be one thing you will notice here is that I will apply this kernel on this image. So you are applying here, then you will apply here, then you will apply here, and then you will apply here. So automatically you can see that I am applying 4 times, right? 3 cross 3, 3 cross 3, 3 cross 3, and 3 cross 3. So I will get 4 outcome, right? I'll get 4 outcome. And all the 4 will be 0 because I'm multiplying this entire thing on this, right? So this will become 0. This will become 0. This will become 0. This will become 0, right? Once that is done, I will apply now in the next slide. Basically, now I will apply to this, right? I'll apply here. Then I'll apply here. Then I will apply here. And then I will apply here. So that is how it will go and hover on the entire image. Then it will further go to the next. It will further go to the next, right? It will further go to the next. It will further go to the next. And it will further go to the next. And same way, it is going to go to the last one also. Further go to the next. Further go to the next. Further go to the next. And further go to the next. So this way, when you hover on this particular edge detector, which is the kernel, it is going to generate 4 cross 4 matrix, right? And once you do the calculation, I already did that calculation from my side to save the time. You will get the number like minus 1020, minus 1020, minus 1020, minus 1020. Basically, I'm multiplying this with this, 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 and this with this. So basically minus 1 into 225 plus minus 2 into 225 into 2 plus minus 1 into 225. When you sum it up, you will get 1020. And same way here also the same thing will happen. This will become 1020, 1020, negative, 1020 and 1020. And this will become 0 because you are going down here. Plus and minus will become negative, right? Plus 225 minus 225 will become negative. So that is how you can see this image is coming in, and you can see clearly in this image, in the center part, I am getting certain information. In the center part, I am getting certain, because you can see my interest is what? My interest is to get this edge. And that is the edge which I got in this particular image, right? So that is how we apply various different types of kernels. As of now, I just have mentioned you one kernel. We will have multiple types of kernel coming in, which will look for the face, look for the object, look for the edges, look for the anything, right? So that is how we can apply various kernels. And based on that, I will try to fetch out the important information. Once I'm applying this 1, 2, 3, 4 kernels, you can see outcome is also coming like that, right? First one is giving me the edge. Second one is giving me the face. Third one is giving me the car image, and so on and so forth. So it will give me all the information from the convolution layer, and it is going to the next layer, right? So that is how machine reads the image and get me the input, which are like important information from that particular input. So that is the first step, right? Which is basically applying the kernel on the image, which is also known as convolution layer. Convolution. The second step which we have is there can be a chance, right? This step is again one of the, what do you say? Not compulsory step. It purely depends on how your image is. Based on that, you can decide. For example, let's say there is an image and there are a lot of people in the image, right? And let's say this guy is very much outside the image, right? But I want to capture his information as well. Because when we are applying this kernels, it reduces the image size, right? It basically taking the important information and reduces the image size. So what I want is I want this guy. I don't want that this guy should miss from the image. So what we do, we apply a padding concept, right? There is a padding concept. I will apply the padding on the image so that any information which are present in the edges will also not missed by the machine. So basically there is a concept of padding. There is a concept of padding which I can apply to take care of the objects or people in the edges of the image. For that, what we do is let's go back to this this example where we have the zeros. So let's say this is my image. Right, all are zeros here. And all are 255 here, right? I'm just writing 25 to save time. And now what I will do, I will add a zero padding. We can apply various different types of padding. Normally people are using the zero padding. So I'll add the zero padding here. So basically I will add zeros. We are adding a pad, right? We are padding my image so that any important information which I have, I will not skip it. For example, now my image is ready with zero padding. Now I will apply this, this kernel. So in that case, what will happen? I will basically start doing from here, right? I will start doing from here. So you can see this edges. If I miss something in the edges, I can very well capture that, right? So this filter will apply here. Then the filter will apply here. Same way this edge will be also taken care. Same way this edge will be also taken care. And same way this edge will also be taken care. So that is the reason we are applying the padding. If there are important information present in the edges of the image, I can capture that. So that process is known as padding, which is again not very much compulsory, but yes, if required, we can very well go for it. We can very well do that, right? So that is about the padding part. Now, once padding is done, one more important concept which we have is known as pooling, right? Before I come back to the original ANN concept, I have to do one more step, which is known as pooling. Let's try to understand what it is. Suppose, let's say, after doing this all process, right? After doing this all kernel process, I get one matrix. Let's assume the matrix is like this. This is my final matrix, which I got, which is a 4x4 matrix. And in this matrix, let's say I get this information 1, 1, 2, 4, 5, 6, 7, 8, 3, 2, 1, 0, 1, 2, 3, 4, right? Let's say I did all this, all these steps. And finally, what I got is I got this matrix where the bigger number means important information, right? 6 is a bigger number, 8 is a bigger number, 4 is a bigger number, like that. So bigger number, 7 is a bigger number. So bigger number means some important information is coming in. So what I will do, I will apply the concept of pooling. There are different types of pooling available, max pooling, average pooling, a lot of different poolings are available. Let's say I'm applying the max pooling. The purpose of pooling is that from the image, the information which you captured, from that captured information also, I am only looking for very relevant information, right? I have a big image from the, kernel part. I got the certain information from the image. And now from that information also, I want more relevant information. So max pooling is basically only going to go ahead and pick up the important information. So let's say I'm applying a max pooling on this. It's a 2x2 max pooling, which I will apply. So what it will do is it will look for important information in this 2x2 matrix, which is the bigger number. 6 is the bigger number. So it will generate a final outcome. The final outcome will be what? You are applying this 4x4 in this image. So it will hover here, it will hover here, it will hover here, and it will hover here. So it is going to give me 4x4 matrix at the end. So from this, what is the bigger number? The bigger number is coming out to be 6. So 6 coming in. Now again, I will apply on this. I can apply like this also. I can apply, if you want more information, you can apply on the middle 4 matrix also. That is up to you, right? You can apply that also. In that case, it will become 3x3 matrix. When we are doing only this, right? This part and then this part, then it will give me 2 cross 2 matrix. So that depends how much information you want to capture from the image. Let me talk about both the scenarios. So in this, I will get now 8 is a bigger number. So 8 comes in. Then what will happen? Then it will go ahead and it will pick up this guy. Bigger number is 3. So 3 will be coming in. And finally, I have this guy. And here the bigger number is 4. So 4 is coming in. So this is my final information which I got from the image, right? So that is the first way. Second way is, again, I have the same matrix. And I am passing the numbers 1, 1, 2, 4, 5, 6, 7, 8, 3, 2, 1, 0, and 1, 2, 3, 4. Right? This is my image. Now I will apply the same max pooling, that is 2 cross 2 matrix, which will give me the maximum from that matrix. I'll apply like this. My first matrix on which I will apply the max pooling. 6 is the max value. So let me create the matrix here. This time my matrix will be a bit bigger. Here the matrix was 2 cross 2. This time this matrix will become 3 cross 3. Why? Let me show you. So now out of this we have 6, right? So 6, I will put it here. Next I will do hover on what? I will do hover on this middle matrix. And the max information is 7. So I will go and I will write 7 here. Then let's say I'll hover on the last matrix. So this will be 8. So I'll get 8. Then I will apply on this part, right? Here the maximum is 6 again. So 6 coming in. Then I'm applying on this part. Here the maximum is 7. So 7 coming in. And here I'm applying on this part where the maximum is 8, 8 coming in. But you can see that you're actually getting the same information. That's why I went ahead with this 2 cross 2 matrix, because it will help me to only get the relevant. Here I'm getting the relevant information, but I'm getting multiple times, right? So that is quite repetitive. So in this case, you may get this type of repetition as well. Then third scenario is I'll do for this. The maximum is 3. I'll do for this. The maximum is 3 as well. And I'll do for this. The maximum is 4. So this is my information which I got after doing the max pooling. The purpose of max pooling is basically to go ahead and get the relevant information from the from the image. Now, on top of this, again, you can further apply max pooling, right? On top of this, again, you can apply max pooling. We can apply actually multiple times max pooling. Basically, what I did, try to understand the concept behind this. I had this original image. I went ahead and I applied the kernel to get the relevant information from the machine, from the image, sorry. I got this. On that, what I did, I went ahead and I applied the max pooling. So from that kernel output which I got, I am further trying to find out some important information. I got the important information. On top of that, I am again applying the max pooling. From this also, I will get more information, more important information. So more important is only one, which is 8, right? Because 8 is the bigger number. So same way here also, if I go and I apply, like again 2 cross 3, if I apply, what will I do? This bigger is 7. This bigger is 8. This bigger is 7. And this bigger is 8. So you got this matrix 7, 8, 7, 8. And that again, you can apply max pooling and you can say, okay, the bigger is coming out to be 8, right? Bigger information. So that is how we can basically apply the max pooling and try to fetch out the important information from the image. And as much as important information I can fetch out, I will get the final information. As of now, let's go ahead and I will make this. I'll say that, okay, this is my best information. I'm not doing max pooling further. This is my best information. So let's take this image further. So this is what I had. One, 1, 2, 4, 5, 6, 7, 8, 3, 2, 1, 0, and 1, 2, 3, 4. I applied the max pool and I got my final matrix, which is 2 cross 2. That is nothing but 6, 8, and 3, 4. That is the max pooling part. Now, once that is done, the next part comes in, which is known as flattening. Flattening. I am flattening the image. Here you can see that, right? It's a flattened. It's a flattened. Basically, what information you got, I'm just flattening that information. That means this particular matrix will be flattened. So how this matrix will look like? The matrix will look like this. 6, 8, 3, 4. So I flattened the matrix, right? So that is the last part of the convolution. So entire layer which we have in the convolutional layer, this is what the step is happening. So let me revise it quickly. I get very raw image, right? I get very raw image. I am applying the kernel to it to get certain relevant information. I got certain relevant information. I am applying the max pooling on this. And from that max pooling, I am getting further some details from the image. And then from there, I am doing the flattening, right? I'm doing the flattening. So basically, I have this image with n number of size of matrix. I'll get certain output. I'll get certain output, and then I will flatten the matrix. And this flattened matrix will be my input for the neural network. This flattened matrix will be my input to the neural network, right? So this entire steps which we are doing here is part of the convolution, because in the image type of data, I cannot go ahead and I cannot basically directly process that data. And that is the reason all these steps we have to perform, right? To prepare. Basically, I can say that convolution is more like a data preparation technique which we are doing, right? Now, once that is done, everything is fine. We are done with it. We are done with the data preparation. Now what to do? We have to just apply the neural network, which we already discussed in the last session, how we can apply the neural network. So now what I will do is I will go ahead and basically from this flattened input, this flattened output which I got, you can actually consider this as, so the number where 6, 8, 3, 4. So you can actually consider this as 4 inputs, right? X1, X2, X3, and X4. I will have certain neurons in between and then final output, right? So this will be full. You can see here in the image also, it's a fully connected network. So fully connected means all the input will be connected to all the neurons, right? All the input will be connected to all the neurons. And same way here also, it's a fully connected network. And then finally output. Mostly we make this hidden layers as the ReLU layers, rectifier linear unit, one of the activation functions. And this I will make it as a sigmoid function, sigmoid layer or sigmoid activation function, because at the end I want what? From the image, I want to go ahead and I want to find out whether that particular object is what. For example, I'm passing an image of cat or dog, and I want to find out whether the image which I have is for cat or dog, right? So sigmoid function will give me the probability of that image to be a cat or a dog. For example, for cat, the probability is coming out to be 20%, and for the dog, the probability is coming out to be 80%. So chances are very high that that particular image is a dog's image. So that is how this entire flow happens. I got the information from the image about the cats and dogs, and then I am passing this in the network. My machine is getting trained, my weights are getting adjusted, and then finally it is giving me the outcome in the sigmoid function, because sigmoid function varies from 0 to 1, more towards 1. That means higher the chances of that particular thing to happen, more towards 0, lesser the chance of that particular thing to happen, right? So that is how we can get the output from the machine. So convolution layer mostly we are using for the, what do you say, classification standpoint, where I want to classify something from the image, whether this is there or not. Let's say I'm having a lot of images and I want to know whether the rain is happening or not in the image. So I can do that type of thing very well using that. So now based on that, I have created one simple example, which I'll show you now. So this is my data set which I was using for the training purpose. And as I mentioned, I already trained the model because the reason is it was taking a bit of time for me to run the model. So just to save the time, what I did, I went ahead and I created the Python code. I'll quickly go through that. And here is my training data set, which consists of various images of dogs. You can see that these are the various dogs images, different types of dogs. And around, I think 4,000 images are there. Yeah, around 4,000 images are there. And same way, I have a image for the cat also, which is around 4,000 images for various different types of cats and different postures and different like standing, sitting, and all those things. I trained my model on these images and I have the testing data as well, where I have around 1,000 images for the cat and 1,000 images for the dog as well, where I am testing my model, whether the prediction is coming out to be correct or not. Once my model is trained on, I have created the single prediction file where I have put 5 different images, one for cat, one for dog, one for cat, one for dog, and one for cat. Sorry, one for dog. So there are 3 dogs and 1 cat. Once my model is trained, I will use these images and I will check whether actually my machine is predicting whether it's correctly predicted or not for these images. So the idea is what? The idea is I have given machine around 4,000 records of dogs and 4,000 images for cats, on which I trained the model. I can very well test my model on the 1,000 records of dogs and 1,000 records of cats. I can very well test my model as well. Also, I have 5 different pictures. One of that, one of dog, cat, dog, dog. And I am going to, from this trained model, I will pass this image and I will get the prediction. Whether it's a dog or cat, it will predict. Same way for this image also, it will predict whether it's a cat or dog. Same way for this also, same way for this also, and same way for this also. That is what I am going to do in this entire code. Now, before I proceed further and talk about this code or quickly go through the code, I will also highlight here is that this is very interesting concept and we can very well apply on various different domains. For example, let's say I have the lot of X-ray reports, right? And let's say I have a X-ray of brain. And my interest is that I want to predict whether after seeing that image of X-ray report, I want to predict whether the patient is having brain tumor or not, right? So what I will do, I will give various different images of different brains to the machine, where there will be some brains where there is no tumor, in some brains there will be tumor. Machine will try to understand. I will label it that, okay, these are the images which are having tumor and these are the images which are not having tumor. Machine will understand from that and then it will predict. Once I come up with a new report, I will give it to the machine. Machine will predict whether this patient is having tumor or not, right? So that type of predictions I can do, which is one of the examples. Same way you can think of any random example, the way I have mentioned, right? I can give you the various pictures of, let's say cricket is going on and I'm giving you various pictures of stadiums where sometimes rain is happening, sometimes rain is not happening. Right. So basically, I will give the entire picture and machine will see all the information from the picture. It will see the clouds, it will see the lightning and all those details. And then when I pass on the new picture to the machine, where I am not sure whether the rain will happen or not, I will ask machine to predict whether in this picture, do you think rain will happen or not? Right. So it will give me the predictions on that, whether the rain will happen or not. So those type of use cases we can very well build on. But yes, the important thing is that you need a lot of images for that. As of now, I trained my model on 4,000 images. So my predictions may come wrong because I did not give a lot of information to the machine to learn, right? So when we are actually going ahead and when we are doing these type of tasks, the expectation is that you should have a good amount of images and you should have a high quality images, right? But yes, at the same time, when you are going with a good amount of images and high quality images, the training time will increase, right? So that will take a lot of time. So these are the things which we have to take care of. But again, a lot of big machines are coming in, a lot of huge architectures are there for the different machines. So we can very well go ahead and we can do all these tasks. And again, as I mentioned, a lot of software level changes are happening in the field of AI, which I mentioned in the earlier session as well. So now processing the bigger data, processing the huge data is not a challenge at all, right? So now let's go ahead and let's see the last part of this session where I will talk about the code. So let me open my code here. So here you can see that I have imported the TensorFlow, which we also discussed in the last class as well. So I imported the TensorFlow. Here the latest version of TensorFlow, which I have 2.18. Here I have given the path where basically what you say, where my pictures are present, right? If you see that it's in the users Rahul download, the picture is present. So you can see that I am passing this particular information. After that, you can see here, what I'm doing is I am basically going ahead and applying the image generator. It prepares images for training by applying the transformations such as rescaling, zooming, flipping. So basically what it does, this image generator, it will actually take those images, right, which I am giving, the 4,000 images. What it will do, it will take those images and it will shrink the image, expand the image, flip the image, because machine will have to understand all the various possibilities, right? When I'm giving the image, there can be a chance that the cat is reverse, right? Cat is like the legs are up and back is down. So machine, what it will do, it will basically go ahead and do all the flipping. You can see horizontal flip, shear range, zoom. So it is flipping it. It is applying the zoom. It is applying the shrinkage also. So all those things that is doing in this particular code, machine is trying to do in this particular code. So all the images which I am giving it, it is generating various patterns of the image and machine is trying to understand from that images as well, right? So whatever images I'm giving, it is playing with that image and generating different varieties of that image from using this code basically. Then I am passing my training data set. This is my training data set and I'm making my size of the image as 64 cross 64. This is the target size which I want. Basically at the end, the maximum size which I want from my uh, from the images around 64 cross 64 pixel, right? So that is what I am looking for. I will train my images, 32 images per batch, right? Batch size is nothing but 32 images per batch. Class mode is binary because I want to predict whether it's cat or dog. It's a binary classification. That's why the class mode is coming out to be binary. Same thing I'm doing in the testing data set as well. So the way I have done here, the same thing is happening in the testing data set. Here again, you can see image generator is going on. And again, you are saying that the image should be 64 cross 64 because the size of the training is 64 cross 64. So size of the testing should also be the same, else model will not run, right? Model will not run on the testing data because the image's size is different. Then I am again applying the CNN algorithm on the TensorFlow Keras, where we are applying the sequential. Sequential is basically nothing but I'm going ahead and I'm saying that there are certain sequential steps which we are going to run. So that is what it is saying. Filter 32. Filter is already I have mentioned, right? So we have discussed here the kernel or filter, right? Kernel or filter. So I'm applying 32 different filters, right? With a size of 3 cross 3. 32 different filters with a size of 3 cross 3. So machine will randomly pick up 32 different filters and based on that, it will try to come up with the outcome. That outcome will be 64 cross 64 cross 3, which is the input size. And this basically 32 filter will be applied on 3 cross 3 on this image. And based on that, my information will be coming in, right? The way we have discussed here, I have a bigger image, it became a bit smaller. So on the 64 cross 64 3, my kernel will be applied and it will reduce the size a bit, right? So that is the next step. Then you can see the max pool I am applying, which will help me to get the max pool. Stride is basically nothing but something like this, right? What we have discussed here. It was taking this, then it was taking this. It was taking continuous matrix, right? Continuous matrix. And then this. When I'm making my stride as 2, what happens? It will take this. It will take this. It will take now, it will skip this part. It will take this. I'm jumping. Stride is 2. So it will jump 2 and go here. jump to and go here like that, right? It will not hover on the entire matrix like 3 cross 3, then again this 3 cross 3, then again this 3 cross 3, then again this 3 cross 3. No, it will not do like that. It will do 3 cross 3, then this 3 cross 3, and then this 3 cross 3 if padding is there, right? So that is how it will do. It will jump. It will jump. And so when you increase the stride, what happens is that your outcome image will be a bit smaller because you are actually skipping certain thing, right? You are basically jumping. You are not taking the entire, you are not hovering on the entire piece of image. So that's why the size of the image will reduce a bit. Then we are applying again the filter, adding the second convolution layer, 32 filter, 3 kernel size and all. Again, we are applying the max pool. So here what we are doing is we are applying multiple layers. Let me try to understand this entire architecture. So basically what we are doing in this particular model is I have the image coming in. I'm applying my kernel, right? I'm applying the kernel, which is 3 cross 3 on this, 3 cross 3 kernel. Then I'm applying the max pool. Then once I have this, again I'm applying the kernel. Again I'm applying the kernel. And again I'm applying the max pool. Right? And then I'm flattening the matrix. So basically from the image, I got the relevant information. Then I did the max pooling. And from that max pooled image, I'm again applying the kernel and again I'm applying the max pool. That is what you can see here, right? Second layer of convolution. So I'm applying the filter again and again I'm applying the max pool. So basically I'm doing it 2 times, getting the information from the image, getting the very important information. Again from that, again I'm getting the information, again very important information, and then I'm flattening the image. So basically trying to make it more very much sure that my machine will give me the best features for the model, right? So that is what it is doing. Then I'm flattening my image, right? I'm basically making the individual features x1, x2, and so on. And this I'm applying in my network. Here you can see that this is my final network where I am passing 128 neurons, all are ReLU. And then I am passing 1 unit of neuron, which is sigmoid function. Then I'm applying the Adam, applying the accuracy to check the accuracy, and my model is getting trained. 50 epochs, that means epoch we discussed in the very first class that it is basically in the network. It is improvising the weight, right? So let's say this is my network. Here various weights are there. Output will be coming in, some error will be there. It will go back and improve these weights, right? So it will give me the output, go back and improve the weights, give me the output, go back, improve the weights, and so on. So one cycle is known as one epoch. So I am doing it for 50 times, 50 epochs, right? So that is how the things is working on. So if I want to create a diagram for this particular network, how this network looks like. So it's something like this. I got the image. I'm applying the kernel or filter. I am reducing the image with certain information. Then I'm applying the max pool. I am further reducing the image. On this, I'm again applying the kernel. I am further reducing the image. On this, I'm again applying the max pool. I am further reducing the image. And then I am flattening this image. And once I am flattening this image, I am applying 128 neurons. All are ReLU activation function, which is your what? Hidden layer. And then one neuron, which is your sigmoid activation function, which will basically help me understand whether the image is of cat or dog, right? And all are connected, fully connected, right? All are fully connected like this. So this is the entire architecture which we have developed just now here in Python. I already ran this because it was taking a bit of time. So I already ran this. You can see it took good amount of time. Right? It took around, I cannot show that as of now, but yeah, it took good amount of time. And now I will do the single prediction. Single prediction is basically nothing but on these images, which I have in this folder. I want to know whether it's a cat or dog or cat or dog or dog. Right. So let me pass this image on that prediction and let's see what's going on. First one is cat.jpg. So let me pass cat.jpg. And when I run this, you can see it is predicting. And when I say print, you can see it is coming out to be cat. Same way, if I go to, let's say this one, dog2.jpg. So let me write dog2.jpg. Prediction is done. I will check what is the prediction. You can see that the prediction is coming out to be dog. If I go and check for cat underscore dog underscore 1.jpg, which is a dog, right? So let's see. Cat underscore dog underscore or underscore 1. And now when I run this, and you can see dog is coming in. Right, let me run this again. You can see dog is coming in. Same way, if I take this one, it's a cat1.jpg. So let me go and write cat1.jpg. And when I run this and when I do the prediction, you can see that the prediction is coming out to be cat. And finally, the last one, dog1. Let me pass this dog1 as well. And once I do this prediction and once I get this outcome, you can see that the outcome is coming out to be dog. Right. So that is how this entire thing will happen. That is how this entire network got created. And this I can very well deploy in the any web page, and I can start creating this. Start doing the prediction for this. Okay. Is that conceptually making sense? Again, the main idea is to help you understand how things work, right? I am not expecting that you should be aware of entire maths, but the main idea, because this session is for the laymen who are very much new to these terms. So the main idea is that to help you understand about how things happen. There is a good amount of maths behind this, but I just wanted to talk about the basic idea, right? So just let me know if you guys have any doubts. That is what I wanted to cover. I hope this makes some sense.
Okay, I understand.
All right, so I think that is what. Could you explain in brief about the YOLO V5 algorithm and demonstrations? Okay, I'll just check on it and maybe I can add one session on the same. Right, I'll just put it in my notes. YOLO. Does the stride also matter vertically for matrix 2 steps horizontal and then would it go to third row? See, again, stride you have to decide what all information you want to pick it up. And if you want a very detailed information, then we have to go ahead and we have to hover on every stride with stride equal to 1. But I don't want, then I can maybe skip the stride and I can make the stride bigger. What if the input is not an image of cat and dog? What it will predict? Let's see. It will predict something. It will predict something. So let's see, right? Let's take one image. Let me take one image. Again, this is a very basic model which I have created for the preparation, right? So let me see what will happen. Horse. Let's say I'm passing this horse in the model. But again, I have to see whether it is a same size or not. Okay, anyways, let's try. Else I have to fine tune this image, but let's try. JPG. Let me write it as dog3. Okay. See. So here is my code. Dog3. Something happened. Let's see. It's coming as a dog, right? So I did not take care of that as of now, right? So maybe I have to check on the probabilities and I have to check what probability is coming in. Maybe I can come up with some other if else. As of now, it is saying if it is equal to 1. Basically, I am rounding off. If it is equal to 1, then it's dog, else cat. So I think it's coming more of a 1. So I can come up with one more elif condition where if it is very less than like very more like I can say point less than point 0.1, I will make it as a other animal. And if it is between point 0.1 and point 0.5, I can make it as a cat, and above point 0.5, make it as a dog. Something like that. I have to come up with the criteria, right? So as of now, it's predicting as dog because it's a very basic model. We have to fine tune this, and we have to make some logic changes as well. Okay. Jupyter tool, can it be installed and run over a browser? Jupyter is actually a web browser type of tool which I can run on the browser, and it does not require internet, right? It does not require internet. It just, you can see it is running in the local host, but it's a web-based solution, web-based GUI or IDE, I can say. So when you launch Jupyter, it will launch in the browser only. All right, any other questions? Let me know. Any real world example where I can use CNN finance? So there are various scenarios where I can actually go ahead and I can apply, what do you say, CNN in the finance. For example, stock market analysis and pattern recognition, right? Where I can get the different charts and try to find out what pattern is, and I can predict whether the stock will go up or not. Again, you will need a lot of images for the same. Obviously, there is no doubt on that, but that is one of the use cases. Maybe I can use the CNN in the fraud detection of credit card transactions as well, right? Where I will get uh, various heat maps of transaction behavior, right? For a bank, what bank does, bank is actually storing all the information and creating a lot of visuals on the fraudulent transaction, so I'll use those visuals and start creating the model on the same, right? I can do some of the sentiment analysis also using the various articles, various documents. I can find the information. So like again, we have to prepare the data in a way that I can apply. Portfolio optimization, I can apply. I can do a lot of various things using CNN, but your data should be prepared like that, first of all. And it should be like, again, as I mentioned, it should be a report. So report I can convert to an image, and then I can do the processing on that. Right. So at the end, it is looking for an image. So I can convert any report to an image, and I can maybe try to get the information from that. Maybe let's say invoice, I have an invoice image and I want to know whether that invoice is processed or not, right? So that type of thing I can think of. So that depends what is the use case, and at the end I want to give it as an image to the machine, and machine will predict. So that depends on the scenario, and we have to prepare the data on the same lines. Can you tell more about Streamlit? Is one of the packages in Python which is helping us to create the front end, right? So basically, this is made for the people who are not very much good in front end development, like us, right? We are coming from a data world and we are more into playing with the data, and we are not very much into designing of front end like tools like Django, Flask, Node.js. These are some of the tools which are basically used for creating the front ends, and they have a separate developers who can actually create front ends and use these technologies. But for us to create a quick demonstration point of view, I want to come up with certain front end which I can create in the normal coding way. Because see, there is a difference in the coding of the front end. There is a difference in the coding of the back end. So we are more of a backend developer. So Streamlit is designed in a way that we can actually use the concept of backend type of coding, and I can apply in developing the front end using Streamlit. So it's a package in Python which we can take help from and create the front ends. It's not very what do you say? It will not give you very beautiful front end, but yes, for the demonstration purpose, it is fine. And again, if you are looking for more detail, then maybe we can plan one session on that also, right? But that is the idea, that if you are coming from a non front end type of developer, you can go ahead and you can use that for creating the quick demonstration type of POCs which you are trying to showcase. You can use that. Okay. All right. So that is what I wanted to cover. Next session we will have next month, where we are going to talk about recurrent neural network and encoders, decoders. And yeah, that is how the things will continue. And we'll have more sessions coming in. Again, the purpose of these sessions is just to help people who are not having any idea of these things, right? So that's the reason I'm not covering more in detail, and that's the reason I'm taking session for only 1 hour, right? The main motive is that to give you the idea, give you like educate you guys that okay, these are the things happening and this is what we can do. After that, if you're interested, you can explore the things from your side, right? So it's like a brief overview is what I wanted to give, and that is what I'm trying. I hope this session makes sense. We'll see you in the next one. Till then, take care, guys. Have a nice day.